All right, so this is finishing up section 1.4. We're going to talk about continuity of some special functions and also look at the intermediate value theorem. All right, so let's first look at continuity of a piecewise function, continuing on from the previous information. Okay, so let's look at an example. I'm going to ask you to find the value of A that makes the function continuous. Okay, so here is our function. It's going to be f of x equals x cubed when x is less than or equal to 2, and ax squared when x is greater than 2. All right, so we know that we want to make sure this is continuous. The only spot where it could possibly be discontinuous is at x equals 2, okay, because we have a jump in the graph. We know, or not jump, but we could have a jump in the graph. We know x cubed and x squared are both continuous functions. So what we're going to want to do is we're just going to want to make sure that the limit as x approaches 2, and we'll do, it'd be from the left-hand side of x cubed, needs to equal as we approach it from the right-hand side of ax squared. So let's see if we could just plug and chug. It looks like I can plug in 2 to both sides, so I don't need to use a strategy, one of the 4 strategies if it was indeterminate. However, you could still find if it was indeterminate, you just have to use one of those 4 strategies. All right, so if I plug in 2, okay, I'm going to get 8 equals 4a, therefore a would have to equal 2. Okay, and you can double check your work by saying, okay, let's just make sure that this could actually work out. So I'm just going to do a check over here. So that means my function f of x would have to equal x cubed if x is less than or equal to 2, and then 2ax, x squared if x was greater than 2. Remember when we worked with the piecewise functions, we would want to make sure it's the same from left and right. So if I plug in 2, get 8, and if I plug in 2 here, I'd also get 8. They are the same, so we are good to go. Okay, so it looks like our answer would be correct of a equals 2. All right, the rest of the time we're going to spend is looking at this idea of the intermediate value theorem, and you should have a sheet that discusses this idea of the intermediate value theorem. It's not really that complicated, but it is a very important theorem in calculus, so we're going to spend time looking at it. So opening question is, if you have an oven, should be if your oven, excuse me. If your oven is 350 degrees Fahrenheit and you turn it off, is there ever an instant when the oven temperature is exactly 170 degrees Fahrenheit? Explain. Well, hopefully your answer would be yes, because as the oven cools, it's going to hit every temperature value between 350 degrees Fahrenheit and room temperature, which is typically less than 170 degrees Fahrenheit. So let's look at more specifically in terms of some functions. I'll do this first one with you, and then you can work on the other ones. I think you'll be doing them in groups. So let's first find f of 1. Should get negative 2. I'm just plugging it into my function here, f of x. If I find f of 2, I should get 17. Okay, so it says, explain why you think the graph of f must cross the x-axis somewhere between x equals 1 and x equals 2. That is, why must there be a number c between 1 and 2 such that f of c equals 0? Okay. Since this graph is continuous, it's a polynomial, there must be at least a point that crosses the x-axis because y changes from negative to positive. Again, it's pretty straightforward, but just want to link it to the theorem. So I'm going to say since this graph is continuous, then there must be a point that crosses the x-axis because y changes from negative to positive. Okay, if I were to plot the graph here from 1 to 2, okay, no, at, go by 5s, this graph is continuous, so we can see it would have to cross the x-axis at some point. If you estimate your 0 on your calculator, it should be at 1.5, 0 approximately. All right, the rest you should be working on this worksheet. If you have any questions, let me know.